Hey guys, Hermson here. Today we're going to be working on applying some of this rational expression stuff to real life. We'll be working on that the next few days. So, I don't have these stapled. That's okay. So, I want to take a trip back down memory lane here. And it says two race cars travel for the same amount of time. The first car travels a distance of 900 miles. The second car travels a distance of 800 miles. If the first car travels 30 miles per hour further than the first car, how many hours? Wait a second, that makes no sense. Okay. If the first then the second car, for how many hours were they traveling? Okay, so I want to figure out the hours. So my two units of measurement would, of course, be hours, but they are traveling for the same amount of hours, so we only list that once. Now, that's your independent variable, and that's going to be our x, okay? Now, the dependent variable is just miles, because even though they don't travel the same amount of miles, that's fine. As long as they travel the same amount of hours, we just need the two units here. Okay, so miles per hour. So I'm looking through that. Two race cars travel for the same amount of time. The first car travels 900 miles. That's not miles per hour. And the first 30 miles per hour further. Okay. So that means there are two of them, but we don't actually know either one. So what I'm going to do is I'm going to put these unknown because of miles per hour. I'm going to call them, let's call them the speed. Okay. So now I don't like S for a variable. It looks too much like a 5. Heck, let's use V, okay? V for velocity. So I use V plus 30, and then the other one's just going to be V. Those are my two speeds, okay? Okay. Now there would be two lines because the rate of changes are the same. So X comma Y, remember this, MX, Y, because it's linear, because I do go for a constant speed. We just don't know what they are. Okay. All right, now, without any hours, we can't travel any miles. Same with that car. So we have what's called a direct variation problem, which means I can go to ratios. Now, that's for car 1, that's for car 2. Okay, so the amount of times were the same. Okay, so therefore I know the times are equal. Well, then if the times are equal, then the ratios of distance to speed have to be equal. And we actually know both the distances. One car traveled 900 miles, the other car traveled 800. Okay, so I just reset this, and I'm going to replace both distance values with 900 and 800. Now, the speeds we don't know, but we actually have written some expressions for them, V plus 30 and V. Now, the one who went the further distance has to be faster, so that's where we want to put V plus 30. Okay, V plus 30 should be with our car that traveled a greater distance, and then this one's just V. Okay, so there's only two ratios on each side. There's no LCD bullcrap. I just look at A, B, C, and D. Okay, and I know that A times B is going to equal C times D. Okay, so A is 900 times the B, which is V, 1V. C is 800 times the V, which is 30, V plus 30. Okay, and then you just do your distributed properties. So 900V equals 800V plus 24,000, okay? All right, so let's get the V's on the same side. So 100V equals 24,000, and then I divide both sides by 100. That's going to be 240. The velocity is 240. However, that's not what we're finding. There's no way this took 240 hours, guys. I mean, think about it. Think about it. But now that I know V is 240, I can replace these V's both with 240, okay? And now to find the time, I take the distance divided by the speed. Now they need to be equal because they traveled for the same time. So this divided by this garbage has to equal 800 divided by 240. So what's 240 plus 30? Well, 270. So I take 900 divided by 270. Okay, and I got 3.3 repeating. Now let's see if 800 divided by 240 also gives me 2 point. Oh yeah, same thing. So the hours are 3.3 repeating or 3 1/3, something like that. Okay, so I'm going to do another one like that. Two runners run for equal amounts of time. The first runner runs a distance of 1,600 meters. The second runner runs a distance of 1,400 meters. The first runner averages 5 meters per second faster than the other racer. Find the time each traveled for. So they want to know time, which in this is the seconds. Okay, so seconds, obviously a very important unit, and then the other unit is meters. So I apply X to the seconds, Y to the meters. So per. Meters per second. Well, if I'm looking at it says here's meters per second, but it says faster, okay? So that means I really don't know the meters per second, but it's a velocity, so I call that V plus 5, and then the other one can be V, because it's two different speeds. Okay, we can make the lines. They are linear equations, but you're not going to make a MX line out of it because this is direct variation, because without any seconds, we're not going to be traveled any meters, so that's a direct variation. So I can use my ratios, one for each car, and it says they equal amounts of time. Remember, it has to say the times are equal. Okay, and I know that time is equal to the distance divided by the speed, or the velocity. Okay, now we actually know the distances the runners run flat out. We know one of them's 1,600 and one of them's 1,400. Now the speeds are the unknowns, but I can put V plus 5 here and then V for that. So now I can solve the equation for B using the A times B, C times D method. Okay, so A times B, we're going to have 1,600 multiplied by V, or 1V. We're going to have 1,400 multiplied by 1V plus 5. So I distribute, and I get 1,600V. That's 1,400V plus 7,000. Okay, I can get the V's on one side. So I have 200 times V equals 7,000, and then it's time to divide. But we don't want to just put that there because the V is the meters per second. That's not the actual seconds, okay? 35, okay? So the velocity is 35, okay? All right, so we're going to put 35 and 35 because I know that the time, if I want to find the time, the seconds, that's dividing the distance by the speed, and they should be equal, okay? So I take 1,600 divided by, that's 40, okay? 40, okay? Now let's see if 1,400 divided by 35 is also 40, okay? 40. So the seconds they traveled is 40. Okay, now, you might want to pause the video and go do number 1, okay, on the assignment. That would be smart on your part. Because I've got some more, but they're not really like that one. Okay, and here's the next one. And I'm not going to be making a lot of boxes because they're talking about average. This is what we call upping the average. It's really good for like figuring grades and things like this. So far I've made 40 of 50 free throws. About how many free throws do I need to make in a row for my average to hit 90%? So it's changing averages. Now this ratio is going to be what I want my average to wind up at. I want it to be 90%, And then any percent denominator is 100%. Now over here I'm going to put what I have so far. Well, I made 40 of 50. Well, the problem is that's not 90%. 40 out of 50 is, if you take 40 divided by 50.8 but times 100, that's 80%, okay? So we need to add to how many free throws we make, but then that's going to automatically add then to how many I've attempted, okay? Because if I make the next one, I made 41, but then I'll have attempted 51. If I make the next two, it'll be 42 out of 52, and so forth. Okay, so I'm going to put ones in front of these, and I just go to my ABCD procedure. So 40 plus 1x is going to be multiplied by 100, and then 90 is going to be multiplied by 50 plus 1x. Okay, so distribute 100 to both these, and that ends up being 4,000 plus 100x. Okay, the other side, 90 times 50 is 45, 4,500 plus 90x. Okay, now my x's are like terms, so let's just get them on the same side first because I can collect all those. So it's 100x plus 4,000, then 4,500. By the way, if you want to trial and error this, I'm perfectly okay with that, but you need to get the answer right. 100x equals 500. I divide by 100. I divide by 100, and x equals 5. Now, you can always check your answer. Then I'll have made 45, and I'll have attempted 55. Is that going to be 90? Wait a second here. Did I do something screwed up here? Because that doesn't make 90% average. Oh yeah, that's because 100 minus 90 is 10. Okay. So I divide by 10, it's 50. Okay. So then I'll be at 90 made free throws out of. So I have to make my next 50. Okay. Again, I checked my answer. I knew that wasn't right, so I went back and inspected. That's okay. So far, I've made 20 out of 30 free throws. How many free throws do I have to make in a row for my average to raise to 75%? So we want our average to end at 75%. That goes over 100%, and we made 20 out of 30, but that's not 75%. That's well short. It's 66%. So I add to how many I made, and then that automatically adds the same thing to how many we've attempted. So A, B, C, D. Because there's only two ratios, one on each side of the equation. So this is what I want to do. I don't want to mess around trying to find LCDs if I can help it. Okay, so A multiplied by B equals C multiplied by D. So A is 20 plus 1x, and B is 100. C is 75, and D is 30 plus 1x. Okay, let's see if this idiot can get it right this time. So I take 100 times 20. That's going to be 2,000 plus 100x. 75 times 30, it's going to be 2,250, I think. Yep. Plus 75x. Okay, let's collect the x's on one side. So 25x plus 2,000 is equal to 2,250. Okay, then I subtract 2,000. And 25 times x is 250. Divide by 25, divide by 25, and x is equal to 10. Okay. So if I make 10, my next 10, I'll have made 30, but I'll have attempted 40. And 30 divided by 40 gives me 75%. Okay, pause the video and I would go do number 2 if I were you. Okay, and the next ones are kind of stupid, okay? It says to join a rock climbing gym, you must pay a registration fee of $100 and a monthly fee of $59. How many months will it take the average cost to reach $69? Okay, this one's kind of a weird one. Just do it as best you can. Okay, again, I want my average to rise, okay? I want it to be $69, but it's $69 per month, so I put 1 month beneath it. It's for 1 month. Now, where are we currently at for money? Well, I paid $100 just one time, and then I'm paying $59 every month, so plus 59x, because I don't know how many months that's going to go on for, okay? Now, and you're like, well, how many months? Well, remember, $59 per month is X, so the actual number of months we're also going to have is X. So A, B, C, D. This one's kind of a weird one. I don't really like it. I like the other two. So A, 100 plus 59X times 1, and then C times D, 69 multiplied by X. Okay, so you're going to have 100 plus 59x, and on the other side, 69x. Then we get 59x. So 100 equals 10x. Divide by 10, divide by 10. So 10 equals x. Okay. Now you can always check your answer. So if it's 10 months, I'll have paid $100 plus 59 times 10, so $690, and there will have been 10 months that have passed, so I divide by the months 10, and it's 69, so $69 per month. Okay, next one. A printer makes 3D models of cars. The printer itself costs $24,000, and the material for each model costs $300. After how many months does it take the average cost per model to hit $700? Okay. So again, they want that average to end up $700, and that's per model, so it's for one model. That's what per means. Okay, so dollars and models. Well, the dollars, well, they paid for the printer once, $24,000, plus $300, but that's for every model, so we don't know the models, so that's X. And then the models itself, we don't know how many that is, so that's X. So A, B, C, and D. So 24,000 times 300x times 1, and we're going to have 700 times x. Okay, so 1 times 24,000 is 24,000 plus 300x. And the other side, I'm going to have 700x. Okay, so we know we can solve for x pretty easily here by subtracting 300 from both sides. Okay, so I have 400x over here, and I've got 24,000 right here. So now I divide by 400. So 24,000 divided by 400 is 6. Okay, so it needs to sell